Hi everyone, my topic is fluid mechanics in a water rocket launcher. A water rocket launcher is a practical application of fluid mechanics that uses compressed air and water to generate thrust. When the rocket is launched, the compressed air passes water out through the nozzle at high velocity. This converts pressure energy into kinetic energy, producing thrust that propels the rocket up.
So as you can see in the slide, here are the anatomy of the blue wing water rocket. In the anatomy, we have a clear plastic bottle body as a body, blue triangular fins, clear adhesive tape, water propellant, and also launch nozzle.
The objective of this study are to investigate the fluid mechanics principles involved in a water rocket launcher, analyze the relationship between pressure and thrust generation, study fluid flow through the nozzle, and examine how water velocity affects rocket performance. The scope of this study focuses on the launch phase of the water rocket. It includes the analysis of pressure, fluid velocity, and thrust generation using Bernoulli's equation, the continuity equation, and the conservation of momentum. Factors affecting launch performance and efficiency are also discussed.
Assignment. Alright. The methodology to build a water rocket launcher has several significant elements that need to be considered for ensuring the rocket launcher fully functional. The important elements for building water rocket launcher including structural, mechanical, and safety components. The aspect of structure for building water rocket launcher including base frame as a foundation, launch tube, rocket holding mechanism, release mechanism, air supply system, pressure gauge, air valve, launch rate, and safety distance system as an alternative. So as you can see in the slide, here are some of the methodology flowchart for this group assignment of building water rocket launcher. Let's move to the review. The water rocket launcher has become common and practical study for students to understand the application of air pressure creating thrust. This practical helps students to apply the knowledge of air pressure, thrust, aerodynamics, and projectile motion in this development of water rocket launcher in the way of physical load, practical.
For the analysis part, our water rocket launcher is explained using the principle of fluid mechanics. When the air inside the bottle is compressed, it creates internal pressure that forces the water out through the nozzle. The high-speed water flow then produces thrust, which pushes the rocket upwards. For this calculation, we assume that the internal pressure is 300 kPa and the density of water is 1000 kg per cubic meter. By applying Bernoulli's equation, we can estimate the exit velocity of the water. Based on the calculation, the water leaves the nozzle at approximately 24.49 meters per second. This means the compressed air energy is converted into the kinetic energy of the water jet. Next, the thrust force is calculated using the momentum equation, where thrust is equal to the mass flow rate multiplied by the exit velocity of the water. Assuming the water mass flow rate is 0.5 kg per second, the thrust generated is 12.25 Newton. From this analysis, we can conclude the compressed air inside the bottle generates enough pressure to eject the water at high velocity and produce sufficient thrust to launch the rocket. In addition, the results show that increasing the internal pressure will increase both at the water exit velocity and the thrust force, which can improve the rocket's launch performance and allow it to reach a higher altitude. In conclusion, this project successfully demonstrated the application of fluid mechanics principle in a water rocket launcher. The analysis showed that compressed air pressure is converted into kinetic energy, producing thrust to launch the rocket. Using Bernoulli's equation and the momentum principle, it was found that higher internal pressure increases water velocity and thrust, improving rocket performance and launch altitude. Overall, all project objectives were successfully achieved while providing a practical understanding of how fluid mechanics can be applied in real-life situations.